In this video, we're going to talk about dynamic equilibrium. And so let's just think about a reaction in general. So when we start a reaction, and we're going to say we have all reactants and no products, we're going to start making products by using reactants. In terms of concentrations, the amount of stuff that we have, the amount of reactants decreases, and the amount of products we have increases. And what that means in terms of reaction rate is that the rate of going from reactants to products slows down, while the reverse rate, going from products to reactant, speeds up. And eventually, during a reaction, you're going to go to a point where, like I said, your products are going to start reverting back to your reactants, assuming that your reaction is set up in such a way. By that I mean if your products are being used in another reaction immediately, then obviously they can't go back to form reactants. And so as the reaction goes on, we make more and more products, and so our reverse reaction rate will increase. And reactions that are like this are called reversible. So if your reactants can go to products, and your products can go back to reactants, and that's what this double arrow is showing, you're saying that this is a reversible reaction. And eventually, you're going to get to this point which we call equilibrium. So your forward reaction rate going from reactant to product slows down, your reverse reaction rate going from products to reactants speed up. Eventually, these two rates will be going at the same exact speed. That is what we call equilibrium. Equilibrium is when your forward rate, reactants to products, is the same speed as your reverse rate, products to reactants. And what that means when you're at equilibrium is that your concentrations of both your reactants and your products no longer change. Since the rates are going the same speed, your concentrations don't change. And we can look at a graph of this. So let's look at the reaction of H2 plus I2 goes to 2HI. If we just look at the graph, which is concentration versus time, you can see that the H2 and I2 concentrations will drop, while our product HI concentration will increase, and at some point we'll reach equilibrium, where their forward reaction, reactants to products, same speed as our reverse reactions, products to reactants. Therefore, our concentrations do not change. We can look at this as time points as well, if that helps you out. So we can say at time 0, we have a certain amount of reactants, no products. After 15 seconds, we lose some of these reactants and make products. 30 seconds, we have more products than reactants, but after 45 seconds, our concentrations do not change because we are at equilibrium, right? One thing to keep in mind though, equilibrium does not mean equal. So when we talk about equilibrium, all we're talking about is the speed of the reactions, but the concentrations are not equal. They could be, but more likely they are not. As we saw in the previous slide, when we were at equilibrium, we had more products than reactants. That's really key to keep in mind. Something easily to get confused, but when we talk about equilibrium, it is not concentration, it is speed of the reaction. And during this reaction, the reactions are still going. The forward and the reverse reaction are still happening, just at the same speed. Now, if your reaction reaches equilibrium when you have more products, we say that the equilibrium favors the products. If your equilibrium happens when you have more reactants, we say that the reaction or positional equilibrium favors the reactants. And that's your overview of dynamic equilibrium. I'll see you in the next video.